Okay, guys, so I wanted to start going over this question. So there are 4 questions on this quiz. You guys seem to do a lot better on this one than the last one, which is great. But if you did have trouble on the last quiz on seasons, I'm going to post the answer sheet with a video explanation for you. So please look that over if that's something that you're struggling with. This is the easiest way for me to really reach everybody is to make these videos. So the first question here says the sun's apparent path through the sky on this day is a direct result of the what? So is it the sun's revolution around the earth? Is it the earth's revolution around the sun? Is it the sun's rotation, or is it the earth's rotation? So I would use the elimination strategy here. I would eliminate A and C first. The sun's revolution around the earth, that's not what happens. Okay, so that's not even possible. Sun's rotation has nothing to do with this. Earth's revolution around the sun, that is a thing that happens, but that is actually what causes seasons. And then we have the Earth's rotation. So the Earth's rotation is what causes the sun to appear to move in the sky. It's also what makes the stars appear to move. That is going to be the answer to this question. So number 1 is going to be D. And I know that your questions were in a different order than mine are, but this is the order that I have. Next question. What time of day is shown by the sun's present position at location A? So we're really going to focus in on this location A. Is it midnight, morning, afternoon, or noon? Okay, so I'm only looking at A, and some of the things I really want to look at here is I have labeled north and south. I also have labeled the apparent position of Polaris, and I have Z, which is the zenith, also labeled. The zenith is directly overhead. Doesn't necessarily mean a lot, but just so you know where that is, the position of Polaris is going to give you your latitude if you measure this angle here. So it's telling me I'm in the northern hemisphere. It's telling me that probably somewhere around 50, 40 something degrees north of the equator. So then I have north and south. So I know the sun is over here. So I also know that the sun rises in the east and sets in the west. So if this is north and this is south, that means that this is east and this is west. So if the sun is rising in the east and setting in the west, the sun is definitely closer to setting than rising. So I could go ahead and eliminate morning. I'm going to eliminate midnight because that doesn't make sense. The sun's not out at night. And I'm going to eliminate, so sun's not out at night at this latitude, right? Maybe other places, but not where this location is. I'm going to eliminate noon also because at noon, the sun would be right around here. So the answer to this question has to be C, afternoon. Okay. Let's look at question 3. Which observation about the sun's apparent path of its location on June 21st is best supported by the diagram? So we have a diagram that represents the apparent daily path of the sun across the sky in the northern hemisphere on the dates indicated. So June 21st, December 21st, September, and March. So we have these are the equinoxes. This would be summer solstice. December is winter solstice. So the sun appears to move across the sky at a rate of 1 degree per hour. That's not true. The sunrise occurs north of east. Okay, so let's look at east. And sunrise is north of east. That is true in this diagram. So that's probably the answer, but I want to just check everything else. Sunset occurs south of west. So sunset, no, December 21st is going to be south of west. If you're struggling with understanding kind of why it's north of east and south of west and those kinds of things of the diagram, I'm going to suggest you go back and watch or rewatch that video I posted that I put along with the reading. It's a really great explanation of how all of this works. And then the sun's total daytime path is shortest on this date. Definitely not true. This is the longest path. Okay, the sun's out the longest in the sky on June 21st is the longest number of hours of daylight. So we will write the answer is B. Sunrise occurs north of east. All right, and our last question. At noon, on which date would the observer cast the longest shadow? So we have the diagram below represents the apparent daily path of the sun across the sky in the northern hemisphere. So it's the same diagram. So at noon, on which date? Okay, so I assigned you guys this assignment for shadow lengths, right? Oh, this doesn't work. So if we are high in the sky, okay, notice that the shadow lengths are very small. And then as we get lower in the sky, notice the shadow lengths increase. So that's also going to be true if you have a total angle that is higher or lower. So in the summer, at noon, that's when your shadow is going to be the shortest. And then in the winter, that's when your shadow is going to be the shortest, and probably shortest always towards sunrise and sunset, because as you can see in this animation, when it's lower in the sky, you have a bigger shadow. All right, so knowing that, we're looking for where the angle is lower. So the angle is lowest on December 21st, so the answer to question 4 would be C. Okay, so I hope that that helps you guys understand everything from this topic. We are going to continue on tomorrow learning about insulation. As always, I'll be available for my office hours. I may be changing them. So keep an eye out in your announcements tab in Google Classroom for any kind of announcements that I might need to make. I hope you guys are all doing well, and I will talk to you soon. Bye.